Okay, everyone, last online video for our first week of remote learning. Hopefully any glitches we've been having are smoother for next week. We are going to start by adding a definition on our definition sheet. So if you need to, if you haven't got that out already, go ahead and either grab your definition sheet or your notebook so that you can take notes. Just pause the video if you need to. So we did yesterday graphing logs, and today we're going to be graphing transformations of logs. And so first we just want to look at what those transformation of logs looks like. So that's our next word, transformation of logs. And by now you guys should be getting pretty familiar with looking at what transformation form looks like. So we have our A log of some base, B, doesn't matter, x minus h plus k, where we know that A stretches, compress, or reflects if it's negative. We know that H is our left and right shift, and K is up or down shift. Oops. I'm just going to put up or down. So if you need a moment to get caught up, you can pause. I think it should freeze the screen. But then I'm going to put an example in here. And our example is y equals 3/4 log base 4 of x minus 2. And notice that minus 2 is not in with x, it's outside. So you have to be really careful on this. So our transformations are, it's compressed by 3/4 and it moved down 2. All right, so take a moment, finish those up, and then we are going to be going through a worksheet. So you will have this attached to this assignment. So that's what you'll want to have next is your worksheet that looks like this, graphing log functions and transformations. So pause if you need to go ahead and grab that. So here we have a log that's already been transformed, and it asks, how does this compare to the parent function of just log base 2 of x? And we see that we've had a shift of left 3 and up 4. And we're going to learn how to graph that today. So first thing is you want to graph your parent function of log base 2 of x. We graphed that yesterday, so if you have that same worksheet that we did with the video yesterday, then go ahead and grab that. But I know some of those points are 1, 0, 2, 1, and then 4, 2. So that's the only ones I'm going to graph. I know it says graph 4 points, but with those 3 points you can get a pretty good graph. And I really wish I would have brought all my colors from home, but maybe you guys will want to change the colors for the next part where we graph our transformed function. But just looking at our base function, our domain, if we remember, is x is greater than 0. our range is all real numbers, and our asymptote is the y-axis, which is x equals 0. All right, so it says use transformations on each point to graph y equals log base 2 of x plus 3 plus 4. So what they mean is we want to take each of these points and we want to take them left 3, up 4. So I'm going to go 1, 2, 3, up 1, 2, 3, 4. This point is going to go left 1, 2, 3, up 1, 2, 3, 4. And then this point is going to go left 1, 2, 3, up 1, 2, 3, 4. So you can see that graphing transformations, you're going to want to graph your basic logarithm first and then add in the transformations. So everything should look really similar to the previous graph. It's just left 3 and up 4. And so now notice our domain is, it exists starting at -3 and going to the right. So our new domain is x is greater than -3. Ranges don't change, they're still all real numbers. And now your asymptote, you'll notice, is x equals -3. So what I want you to notice is that whatever this is right here, that shows you your new asymptote. So if it moved left 3, your new asymptote is now -3. So if we put in our points that we had from our log base 2, we had this 1, 0, we had 2, 1, and we had 4, 2. Now, sorry, I couldn't get the tables on the same page, so you're going to have to turn it over. Now we want to look at what our new points are. So, see if I can get this all in one page here. So we look at this new point here. It is -2, 4. Our next point is -1, 5. And our last point is 2, 6. So looking at that, we want to answer this question 7. What do you notice about the two tables? How could you get the numbers in the second table from the numbers in the first table? So let's just do that side by side. If I took this point and I subtracted 3 from it, so here's my new xy, because I moved these points all left 3, so 1 minus 3 is -2, 2 minus 3 is -1, and 4 minus 3 is 1. I must have graphed this one point wrong. Oh yeah, this point is wrong. Sorry guys. This point was supposed to be 4, 2, and I had it at 5, 2. So this point should be here. Let's go back and switch that on our sheet. That should be 1. All right, so now notice when I just subtracted 3 from each of these numbers, my x values match with what I got on my graph. So if I moved all these points up 4, I would add that to the y values. So 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. And now I see I got the same table. So you could either graph, this is like the two different ways we graphed yesterday. You could either graph your base or parent function and then translate all your points individually, or you could take your parent function table and make a new table and graph from that. All right. Now we're definitely on to page 2 and looking at number 8. So they want us to go through these and describe our transformations and use that information to answer question 2. So we're all really good at describing transformations. So we know this was stretched by 5 and it moved right 7. So that's our answer to little Roman numeral I. Our answer to Roman numeral 2 is all affected by this right 7. So my new domain has to be now x is greater than 7. My range stays the same, where my range is still all real numbers. And my asymptote has to be x equals 7. Because now that whole graph was shifted right 7. All right, so let's look at B, and maybe you go through B and C before we go over the answers just to see if you have understanding, so you might want to pause your video here. But I can see this graph has been reflected and moved up 5. Notice there's no left or right shift. So this is my transformations. Since there's no left or right shift, that means my domain did not change. It's still x is greater than 0. My range is still going to be all real numbers. And because it did not move left or right, my asymptote equation is x equals 0. So only our left or right shift switches the domain and the asymptote. And then finally, we have the last one. We are compressed by 1/3. We see here that I have moved left 6, and this part is down 8. So compressed by 1/3, left 6, down 8. You can get rid of that little extra comma there. All right, so that's the first part. We did have a left or right shift, so our domain is going to change. So our domain is going to be x is greater than -6 now. Range never changes for logs, so it's still all real numbers. And since it did move left 6, then I have a new asymptote equation of x equals -6. All right. So your homework tonight is going to be filling out a worksheet that's really similar to this. Anyway, I hope you have a great weekend. All of this will be due on Monday. Take some time away from the computer because we've all been on it too much this week. And then I will have something new for you on Monday. I'll post it Sunday night.